So we have an application. It says Batman throws his batarang upward with an initial velocity of 60 feet per second from 20 feet above the ground and has a velocity modeled by v of t equal to negative 32t plus 60, where t is the number of seconds after it was thrown. Part A, determine a distance function and find the height and velocity. Okay, so this problem is pretty deep problem. We have to know a couple things. First, we have to know our relationship between position, velocity, acceleration, and what that means. Like if I have the position, is the velocity the first derivative or the second derivative? The other thing we have to do is understand this 20 feet above the ground aspect. So before we do that, let's just do a little bit of a summary here about position. So if I have position, the derivative of position is your velocity. The second derivative of position is the derivative of velocity, which then gives us the acceleration. So if we have position, first derivative of the position is velocity, second derivative of position is your acceleration, which is the first derivative of velocity. Those are extremely important to know because we're given here the velocity, and we want to determine the distance. So if we want to determine distance, we want to go from velocity back to position, because the position will tell us the distance. So let's go ahead and integrate this function here. So we're going to have the integral of negative 32t plus 60, and this is going to be dt. This is t to the first, so this is going to become 1 plus 1 over 1 plus 1. So I'm going to have negative 32t squared over 2. That's going to simplify. We have a constant of 60, so this is going to become 60t plus c. It's extremely important here that we remember the plus c. And then I'm going to just simplify this, clean this up a little bit. So negative 32 divided by 2 is negative 16t squared plus 60t plus c. So here's where this is coming into play to figure out c. It says from 20 feet above the ground, that is going to be part of this this process here. So this is our position, and this is the initial throw. So the initial velocity was 20 feet above the ground. So that means for all the values of t, we're at 0. So we're pretty much doing this 0 and then 20. So I'm replacing t with 0 because it's at 0 seconds. That was the initial point that it was thrown. So at t equals 0. And then I'm going to change the position to 20. So I'm going to have 20 equals negative 16 0 squared plus 60 times 0 plus that constant. This is 0. Negative 16 times 0 squared is 0 plus 60 times 0 is 0 plus c. So what we're going to end up with is c equal to 20. So now we actually have a c value. We're able to get this constant of integration being 20. So our position, which is going to be our height function, and we could actually just write that as h of t rather than s of t. So I'm just going to go ahead and just do that underneath since we have this function h as a function t. So h of t is going to be negative 16 t squared plus 60t plus that c value of 20. And we got that c value based off of this information of the initial point that it was thrown. It was thrown 20 feet above the ground. And that was the initial throw, so there's no time elapsed. So t equal to 0, and we're going to equal to 20 there. So 0, 0 plus c is equal to 20. Nice. We have our function of h. That was our distance function. Part B, so I'll split this with A. Part B, we are going to have find the height and velocity after 3 seconds. Move me out of the way here for a second. So we want to find the height and velocity after 3 seconds. So that means we are going to take the height function, plug in 3 seconds. We're going to take our velocity function, plug in 3 seconds, because we just want to know the height and velocity after 3 seconds. So plugging in 3 into our height function is just going to be negative 16 times 3 squared plus 60 times 3 plus 20. So it's going to be negative 16, 3 squared, plus 60 times 3, plus 20. So that's 56. And that's going to be feet, right? I think we're talking in feet. Yeah, feet. So the height after 3 seconds is feet. And then the velocity after 3 seconds, that's plugging in into now the velocity function. So the velocity function was we were originally given. So now we're going to do v of 3. So this is going to be negative 32 times 3 plus 60. So negative 32 times 3 plus 60 is negative 36 feet per second. And we always want to make sure you can understand the interpretation of this information, especially with these applications. A height of 3 means after 3 seconds, it's at a height of 56 feet. The velocity is negative 36 feet per second. What does that negative mean? Well, since it's negative, that means it's going in the downward direction. It is going down. So that means if we were to look at a graph here, the object has gone up, it's gone down, and after 3 seconds, it's on this downfall here. So it's at 56 feet, and it's traveling down. It's going down. So just making sure you understand the actual interpretation there of these applications.